I wanted to go over the details of the force table example that we did in class today. And so I wrote it up, and on the bottom here I did a graphical solution, and then on the top I did an analytic solution. So starting with the graphical solution, the first thing I did is I drew a scaled vector F1 that was with the lighter mass on it. So that was a 50 gram. It was just the mass hanger by itself, which translates to 0.49 newtons if you multiply by 9.8. And I'm going to scale that to be 25 millimeters. The other one, F2, had the twice as much mass on it. It had 100 grams, which translates to 0.1 kgs. 0.98 newtons, again if you multiply by 9.8, and that would be 50 millimeters in length, because twice as much force, twice as much length. And then you have for F1 20 degrees to the left, and for F2 20 degrees to the right. And so if you add F1 and F2 together, and so what I did to do that is I moved F1 down here and then drew this vector. So this vector right here represents the sum of the two. And so I measured the angle, and it's 7 degrees. And then I measured the length and then translated it back to newtons. So 1.37 newtons, 7 degrees. Well, if F1 plus F2 is this vector, it means that F3 has to be the negative of this vector, which would be this guy right here. And so this guy is going to have the same length, F3, 1.37 newtons, and it's going to be 7 degrees to the left of north. And so my graphical solution gave me an F3 that had 140 grams on it, 0.140 kilograms, and 7 degrees to the left of north. Okay, on the top, I've done the graphical solution. So F1 is represented by this vector. If you look down at F1, you'll realize that it's gonna have a negative y component and a negative x component and a negative y component. So you're going to see two negatives here for F1. Sine of 20, cosine 20 respectively for the x and the y. And the reason the sine and the cosine are switched is because the 20 degrees is downwards respect to the vertical instead of being with respect to the horizontal. And so that turns out to be negative 0.168 newtons and negative 0.460 newtons. Just do the math on your calculator. F2, instead of 0.49 newtons, you have 0.98. It's twice as much mass on that second hanger. And you have a positive x and a negative y. And so again, if you do the numbers here, this turns out to be 0.352 newtons and 0.921 newtons. And so F1 plus F2 is then, well, the sum of these two numbers is going to give this, and the sum of these two numbers is going to give that. And so that's going to be minus F3. And so F3, therefore, is going to be minus 0.184 plus 1.38 newtons. And now I've drawn a picture over here. So here is the y component of 1.381 newtons. That's this guy right here. And this is the negative 0.184 going to the left because it's negative. Again, I'm bookkeeping with respect to our coordinate system. And so I can use Pythagoras to figure out what the length is here, and it turns out to be 1.393 newtons. And then I use an inverse tangent to figure out what the angle is, and it's 7.6 degrees. And so the exact solution gives me an angle of 7.6 degrees compared with my graphical solution of 7 degrees. So, you know, that's a little bit less than a 10% error. And the comparison for the weight and the mass are 1.393 newtons analytically, and 1.37. And so if you do the math here, it's basically about 1.4% or so, minus 1.4%. Okay, so hopefully, if any of you are having trouble with that problem yesterday, here it is, and I can also post this PDF on the website.